نستكمل ما تبقى من مؤتمر الهندسة الخضراء مع المتحدث محمد الصباغ من استشاري لوسيل، فليتفضل.
السلام عليكم. أولا أحب أتقدم بالشكر لجمعية المهندسين القطرية على دعوتهم لنا. Thank you for the Society of Engineers. Our discussion today will be about the green engineering in the sector of consultancy and investors. Both the consultants and the investors are facing challenges when applying green engineering. And these challenges depends on the actual fact on the public awareness of the people, the public awareness of the consultants and the engineers as well who are working in the consultancy service. Another challenge which is about the law and regulations which may provide an incentives to the investors in order to make use of the green engineering. Another consideration and the challenge, the people should realize the life cycle cost rather than the initial investment of the projects. In addition to that, both the parties, the consultants and the investors, they have to involve from an early stages the financing company as well. Application of the green engineering is a joint effort between the owners, financing firms, the consultants, governments, authorities, contractors, and the facility management. In the coming next slides, we will just review some case studies that has been applied before. This project is a commercial bank of Kuwait, and this has been built in 1985. The idea of the building is that all these here, sorry, I have to take, hello? Yes. All these are glass blocks. The whole building is a glass blocks. Then it is already covered by a precast panels that creating a facade of the building and maintaining an air gap between the facade and the windows. By creating that and using the glass blocks, there was the benefits of a passive solar control that prevents the sun from the direct exposure, creating the air gap which can reduce the temperature, using the daylight as much as possible, and then reducing, of course, the heat gain, as we said earlier. The characteristics of the glass blocks provide as well sound insulation, and the building was provided with a building management system in addition to a light control. So there was a dimming system that will save the energy as well. This is another project which has been created in Egypt in 1995, and that was a resort having 300 bedrooms. And on that project, we have provided in the design centralized domestic water system using the solar panels. In there, while making the design, we have selected the capacity to be about 33% of the total demand of the building, which is covering the requirement of the hot water in the hotel during the summer. By doing that, taking into consideration that the winter season in that area is short, we have optimized the selection of the solar panels in there. And that was a centralized one. We used about 1,000 square meter solar collectors on a land which was about 4,000 square meter. Of course, we were using a circulated hot water system with a circulating pump, and the pipes was insulated. Recently here in Doha, in 2015, we have designed a twin building, residential building, and these buildings has already obtained GSAS 3-star. The building, as you see here, has, oops, I'm sorry. Here, you can see that the building is surrounded with these twisted fins. These twisted fins provide also a passive solar control for making the windows and the balconies not subjected to the direct sunlight. One of the features of the building here, it has been, you can see that in each floor, the view of the residents can see different angles into the sea. In between the buildings, there was a connectivity. So the two buildings on the ground floor was on a podium which has been connected with a shades, okay, that is providing a proper connectivity with some points according to the GSAS. In the building as well, there were a gray water treatment and recycling on that. I will just show you here some slides that and videos that may be providing you the idea about how we come to the idea of the design of the building. As you see here, these are the twisted fins, which is moving, yeah, in a different angles in each floor. So these fins has been designed to create a different view whenever you are in a different floor. That's as well how the design concept has been delivered. Excuse me. You see the fins here, how they are twisted whenever you are going up and the view is being changed. The balconies are, and the glasses are inside the fins. So there is no direct sunlight there. This one will show the same, but from different angle. It's on the elevation side of the building. That might give you a better idea about the angle of view. So you can see that on the upper floors, they are looking to different angles from the lower floors. That's the last maybe example we have it. It was a public parks for the design of these public parks, and these are GSAS 2-star. We have used in there a solar panels, wind barriers, lighting control system, and one of the main issues as well was the connectivity. Will be done. So there was a solar panel used above the car parking area above the shades which they are connecting the parts together. I will just quickly go through the historical development of the green engineering. Maybe you all know about the history of that, but quickly, the main issues started in Stockholm in 1972, where the governments of many countries has been gathered there under the umbrella of the United Nations Conference in order to look into the human environment and the Earth's environmental problems. After this, by 20 years, in the meeting of Stockholm, that was the Rio de Janeiro at 1992, where the draft of Kyoto Protocol has been prepared. In Japan, 1997, and after the meeting for two conference of the parties, which we call the COP, they met twice, and on the third meeting, they have concluded the protocol. One of the disadvantages or one of the major issues happened. It was in 2001 where the United States has withdrawn from the protocol. However, in February 2005, more countries has been signed the protocol, and Russia as well has been signed the agreement. In Qatar, the QGPC Council has been formed in 2009, and this has been established by a decree signed by Her Highness Sheikh Moza, and the council is concentrating about supporting the overall health and the sustainability of the environment, the people, and the economic security in Qatar for the generations to come. Right. When we talk about sustainability, there are two terms there, which is the sustainability and the green engineering. So, by definition, sustainability is the sustainability involves taking action now to enable a future where the environment and living conditions are protected and enhanced. Whereas the green engineering, it's a complete process, okay, for including the design of materials, the process itself, the systems being used, and the devices, with the objective of minimizing the overall environment impact over the entire life cycle of the project. The green engineering historically was considered to be a portion of a project. However, nowadays, it is considered to be a minimum requirement with focus on the applied to how this is consistently achieved. The 12 principles of the green engineering has been developed to enable the engineers to incorporate elements of sustainability throughout all areas of the project in a systematic and comprehensive approach. The summary of the 12 principles are listed here in this slide. We started with principle number 1, which is talking about the inherently non-hazardous material. So while making any design, we have all to check the hazardous material and try to avoid the use of the hazardous material, whether in the input or output. The principle number 2, prevention as opposed to treatment, which is also a better approach, is to prevent the waste than to treat it. So in any process or any design, we should prevent the waste rather than to create it and then to treat it. Principle number 3, design for separation. We have to avoid the separation and purification operations, as it is a costly approach, and then it requires a treatment after that separation. Systems as well may be failed, and then whatever the protection or the system we are going to use it can cause a damage as well. Principle number 4, which is to maximize the efficiency of the products, process, and should be designed to maximize the mass, energy, space, and the time efficiency as well. Principle 5, Le Chatelier principle. This is the principle which has been based on the equilibrium law, which is simply saying that when you are considering a system that it is in equilibrium and you add to this system a more stress, then the system will adjust itself to relieve the stresses which has been added to the system. That stresses can be in a sort of temperature, pressures, which is, while making a design, we have to be careful about the additional values to be added to the equilibrium state. Principle 6, conserving complexity. Be simple. Try to be simple as much as you can. Don't put too many materials or systems that will require in the future maintenance and additional cost as well. Principle number 7 talks about the durability over the immorality. Here we should be careful about the selection of the systems to cover the lifetime of the project. There is no need to add more than what is required in this case. Principle 8, we just need to meet the needs without maximum excess. So reasonable approaches in the design is another factor that always designers should allow for. Minimize the material diversity. As well, we have to keep the number of materials being used in the systems as minimum, as practical, in order to avoid the diversity of the materials, which obviously require knowledge, maintenance, and additional cost to the project. Principle 10 is to integrate the material and energy flows. The design of products, processes, and systems must include integration and interconnectivity with the available energy and materials flow. So we need to use the available energy as much as it is available. Commercial afterlife, this is principle 11, and we have to look to the products, processes, and system should be designed for performance in a commercial afterlife as well. Meaning that if we are using a system and there will be an output from that, we should recognize what we are going to do with that output at a later stage. The principle 12, the last one, which is the obvious one, is trying to use the renewable rather than the depleting resources. I'm sorry, you didn't see the, the other screen here. Okay. In general, the design process is always has its inputs and outputs. And while designing any building or systems, we have to evaluate the inputs, outputs, and to check what is its impact on the atmosphere and the human and the social impact on that one. The process is, once we have decided about the inputs, we go into the design process, which including manufacturing, use, the disposal, and extraction as well. After that, we look into the outputs of the design process and evaluate that with respect to its impact on atmosphere. If we have a negative atmosphere, then we have to go back into the design process, changing our assumption and improve our design. The green engineering, of course, is a better design than the traditional engineering. The common question is, green engineering costly? If yes, how much? Normally, the people are considering the initial investments, and this is the issue which we talked about, that it has to be clarified with the investors from the beginning of the project in order to avoid just only considering the initial investment without considering the life cycle cost. The initial investments, there is two approaches to do that. The first approach is to make an optimum alternative in the design, and this one will lead to an increase in the initial cost between 4 to 12%, depends on whatever you are going to use. The other approach is to go for economical alternative. The economical alternative can make an additional investment of 0.2 to 1.5% of the total cost. Whereas the life cycle cost, considering the impact of the system on the environment, which its cost is not built in the initial cost, has to be allowed. People are paying that through taxes, or the government are paying that as well in some of the countries like here. In fact, the sustainable product or progress provide a cost saving over the entire life cycle, the product process when considering a cost of the operation and the capital cost. This chart here has been indicating what are the life cost cycle cost, which is vary, as you can see, and starting from the concept design and its validation, the concept exploration, the full-scale development, and then the production and the development in that area, then the initial operation capability, and then the out-of-service cost. So all these parameters has to be considered in the different stages of the design, from research and development, the production or construction, and then the system acquisition, the operations and support, in order to reach the life cycle cost. Thank you.